Yeah, good morning. So, in the last lecture, we have covered the whatever syllabus for our advanced concrete technology. So, and various some practicals which we have to perform that, and some textbook and reference book we have seen. So, today we will see the unit number 1, that is on the ingredients of concrete, and the first ingredient of concrete is cement. Okay, so uh, as you have learned the this advanced concrete technology, some of the part in the concrete technology in the secondary civil engineering, but some of the advanced part we have to see in from the unit number 2 that we have not learned. But the unit number 1 is related to some basic ingredients of concrete that we will learn in unit number 1, and then from the unit number 2 onwards we will see some advances in the concrete technology. Okay, so that syllabus we have also discussed in the last lecture. Okay, so so if you see this cement, so what is cement? So generally cement is a binding material which we are using in the mixture of uh, mixtures of calcareous, then siliceous, then argillaceous, and other substance. Means cement is manufactured by using some of the chemical compounds are there. So actually this is the binding material which we are using in the concrete. So generally cement is a binding material which we are using in the concrete. So what are the other ingredients with we are mixing in the concrete? So with the cements we are using sand. Now natural sand is there and crushed sand is there. There are two types of sand nowadays we are using, natural sand and crushed sand, and also we are using aggregates. So with the mixture of aggregate, then sand and cements, we are preparing the concrete. So the first ingredient is the cement, which we are seeing. So cement is a binding material. Then again, the cement is a hydraulic binder and is defined as a finely ground inorganic material. Cement is a hydraulic binder and it defined as a finely ground inorganic material, which when mixed with water forms and paste which set and hardens by means of the hydration reactions. So how cement we are using? So actually cement is a very fine material which we have seen earlier. So uh, and that inorganic material, but which when we mix with the water, जेव्हा आपण water बरोबर cement mixing करतोय, that at that time what will happen, the paste will be happen, that paste will be which sets and hydrate by means of the hydration reaction. It means when the cement we will mix with the water, at that time the paste will be prepared, and that paste will be set or hardened by means of hydration reaction. So what is mean by hydration reactions? So hydration reactions means generally heat is present in the cement because their chemical properties, if we see the chemical properties of the cement, then we will see we will get which materials we have used for making the cements. So depends upon that material, the heat is produced, or heat is a tremendous heat is in the cement. If you open the bag of cement and insert the hand in the cement, what will what you will observe? So there will be the, if you insert the hand in the cements, the heat will be look, आपल्याला heat ते गरम असलेलं असं जाणवतं. It means the whatever chemical composition of that cement is there at that time, the heat is present in the cement. So if we mix with water, the heat is hydrated. the hydration reactions is there. It means ती heat निघून जाते आणि ती heat निघून जात असताना ते पाणी त्या heatला so that water is removing the heat from the cement. So that is the heat of hydration, and a process which after the hardening retain its strength and stability even under water. So hence after if we mix the cement with water, what will happen? The heat is generated, and that heat of hydration reaction will happen, and after that the hardening is retained and the strength and stability under the water is increases. So cement will be the cement will become the hardened for the strength purpose. So this is the nothing but the cement. Then manufacturing of cement. How we can manufacture the cement? So this part also you have learned in the concrete technology in second year also. The India is the second largest producer of the cement in the world as per the 2019 proceeding, 502 million ton of the cement per year. So India is the largest, second largest country in the world which producing the cement. How much cement per year India is producing? 502 million ton. 502 million ton of cement per year India is producing. So the manufacturing is more in India, as India is the second largest country. The cement manufacturing industry share a major part in the Indian economy. See, so various companies you have an Ultratech Cement, SCC Cement, or other many companies are there which producing this cement, and the Indian economy is a major part of Indian economy is depends on that particular manufacturing of cement. The raw materials required for manufacture of Portland cement are calcareous material such as limestone or chalk, and argillaceous materials such as shale and clay. So these materials we are using for the making or manufacturing of the cements. So then cement factories are established where these raw materials are available in plenty. The cement factories have come up in the many region in India. So that it means, as I told, the second largest country is the India for manufacturing of cement. So the eliminating of inconvenience of long distance transportation of raw and finished material. So by using this material, limestone or chalk and shale or clay, by using this material we are manufacturing the cement in the various factories, cement factories. So and we can transport overall India and other than the India various countries. So this is the manufacturing process. We will see again how manufacturers will be there. Again here if you see the process of manufacturing of cement consists of how we can manufacture the cement consist of so grinding of raw material, mixing them intimately in certain proportions depending upon their purity and composition, and burning them into kiln at a temperature of about 1300 to 1500 degrees Celsius. See, what we are doing in the process of manufacturing, we are it is the cement manufacturing process is consist of grinding the raw material. So limestone is there, as I told you, chalk is there, clay is there, shale is there. So that material we are grinding, and for the certain proportion. So depending upon the purity of that material and composition, we are burning them into the kiln. So kiln is one of the unit of the manufacturing process, and in that we are burning at a temperature of 1300 to 1500 डिग्री सेल्सिअस. 1300 ते 1500 डिग्री सेल्सिअस मध्ये आपण काय करतो, किल करतो, सो बर्न करतो. So then at which temperature the material sinters and partially fuses to form nodular shaped clinker. So you have seen this also procedure in the second year civil engineering in the concrete technology. So these are the units, kiln, then clinker. These are the units where we are processing the cement. The clinker is a cooled and ground to fine powder, which addition of about 3 to 5% of the gypsum. So without gypsum, so we are adding gypsum in the cement manufacturing. Why? Because 3 to 5% cement is getting the good binding strength to the cement. So 3 to 5% of cement we are adding. So in the clinker, the powder will be generated, and in that powder we will add the 3 to 5% of gypsum, and then the product form using the procedure is a Portland cement. So whatever, by using this procedure, whatever cement is generated, that is the Portland cement. Again, there are two processes. There are two processes: wet process and dry process of the manufacturing of the cement. So wet and dry processes. So these processes depends upon the weather. The mixing and grinding of raw material is done in wet or dry condition. So in as you know, our country is having wet and dry region. So somewhere very dry region is there, somewhere wet region is there. So depends upon the condition of wet or dry. So we are mixing and grinding the raw material. Then with a little change in the above process, we have a semi dry process where the raw materials and ground dry and mixed with 10 to 14% of water, further burn in the clinking temperature. As we know, the in the semi dry process, where the raw materials are ground dry and then mixed about the 10 to 14% of the water, and further it will be the burn to clinkering temperature. So this wet and dry process we are adopting for processing the or manufacturing the cement. So if you see here, if you see here, the wet process of the manufacturing of cement. So how a wet process is? So initially clay is there. In clay we are adding the water. Then here limestone is there. Limestone we are crushing. Then again storage basin. So crusher, whatever limestone we have crushed, that comes under the storage basin. After the storage basin, it will come in the wet grinding mill to the make slurry. Then clay will be the wash mill, comes under the wash mill. Again it will so again the clay will be the comes under a storage basin, and it will come the wet grinding mill to make slurry. So the limestone and that clay, it will come together, wet grinding mill to make slurry. Here it will come. After that, blending of slurry to correct composition. After that, it will come the storage of the corrected slurry. So the powdered coal and oil gas is there, that will comes under the corrected slurry and fed rotary kiln. So after it will come under the kiln. After that, the slurry is converted into the clinker. So whatever raw material limestone we have crushed, so that mix with the water, then slurry will form. लाईमस्टोनला जर क्रश केलं तर त्याचं काय होणार आहे, पावडर होणार आहे. ते पावडर जर पाण्याबरोबर मिक्स केली तर ती पाण्याबरोबर मिक्स केलेली पावडरचं काय होणार आहे, स्लरी तयार होणार आहे. ही स्लरी कुठं येते, या किल्न मध्ये येते, रोटरी किल्न मध्ये येते. आफ्टर द रोटरी किल इट विल converted into the clinker. So after the clinker, it will um, clinker is a ground in the ball mill, and at that time here the gypsum is added. 2 to 3% gypsum is added. So this will be the MCQ question you will ask. So how much percentage of gypsum is added in the cement? So how much it is added? 2 to 3%. It will be for your competitive examination. It will be for your university examination. So this is very important. The how much percentage of gypsum is added? 2 to 3% gypsum is added in the concrete or cement. Sorry. Then the cement silos is there. It means here the clinker, this in this situation the your cement will be manufactured. After that it will goes into the silo. So सिमेंट भरून ठेवण्यासाठी मोठमोठ्या कंपनीमध्ये सायलो असतात फॅक्टरीमध्ये. अँड आफ्टर दॅट इट विल बी पॅकिंग प्लांट. म्हणजे शेवटी ते परत पॅकिंग केलं जातं बॅग वाईज. सो वी हॅव सीन दी बॅग्स ऑफ सिमेंट. सो that bags of cement we will pack from the cement silos. So very high, big or very high quantity of silos are available in the factories. So that are the cement silos. So this is the wet process of the manufacturing of the cement. So again, you can see the flow chart, how we can manufacture the cement. If you see here, see here limestone boulders from the minerals are there. So these are the limestone. So these will be crushed here. Crusher is there. Here crush will be there. After that crush, here clay will be comes from this side. Here clay will be there. Then this is the conveyor belt. So from this conveyor belt, this will be the move. After that in this direction, the raw mill is there. So to raw mill, this will come into this particular silo. After this silo, it will come in this direction. So 1, 2, 3, 4 stages are there, and after that it will come into the rotary kiln. So this is the rotary kiln. So now here it will be burned. So burning process will be here. So burning, after the burning process, it will be cooled and it will go into the clinker. And here the gypsum is added. Here gypsum is added. How much? 2 to 3%. And from this cement mill or silos it will be. So this is the flow chart. This is the flow chart of the cement manufacturing process. Okay. So here the manufacturing, what is cement and what is the manufacturing process that we have seen here. Okay, so so now physical properties of the cement. So after the manufacturing of cement, how we can test the cement, whether the cement is as per the our industry requirement cement is produced. Whatever cement is produced is as per the industry requirement. So there are some physical properties we have to see. after the manufacturing of cement. So the first physical properties of manufacture of cement is the fineness of cement. So I think that you have also learned in the concrete technology. So first chapter is you have learned already. So here repetition is there. So fineness of cement. So how to test the fineness of cement? So what is first fineness of cement? The size of particles of the cement is a fineness. Size of particles, cement particle size, that is the fineness. So how to test? The required fineness of good cement is achieved through grinding the clinker in the last step of the cement production process. After the last step of cement production, so after the grinding in the clinker, so that fineness is measured after the clinker. म्हणजे मॅन्युफॅक्चरिंग झाल्यानंतर आपण त्याची फाइननेस टेस्ट करतो. सो ओके, सो व्हॉट इज फाइननेस? सो फाइननेस और पार्टिकल साइज ऑफ पोर्टलैंड सिमेंट्स affects hydration rate. What affects fineness? So fineness is affecting on the Portland cement, that is the hydration rate, heat of hydration rate. Thus the rate of strength gain, म्हणजेच it's on the depends on the hydration rate, the strength will be depend. जर हायड्रेशन रेट हा हीट ऑफ हायड्रेशन रेट हा किती आहे त्याच्यावरून आपला स्ट्रेंथ अचीव करण्याचा रेट किती आहे हे आपण फाइननेस वरती डिपेंड आहे. सो फाइननेस इज डिपेंडिंग ऑन द हायड्रेशन रेट अँड इनडायरेक्टली the rate of the strength gain. Whatever strength we will get, that is depend on the hydration rate, and again it will depend on the fineness of the cement. Then the smaller the particle size, then the greater the surface area of the surface area to the volume ratio. So I think everyone has know how to test the fineness. So generally we are taking the cement on the आपल्या हातामध्ये घेऊन सुद्धा आपण त्याची fineness टेस्ट करू शकतो. Or one of the sieve size is there. So by sieving this size, how much percentage of particles retained from this particular sieve? So that in this way again we can test the fineness of the cement. So the smaller particle size and greater surface area, म्हणजे हातात घेतल्यानंतर त्याचा surface area हा जास्त व्हायला पाहिजे, and the particle size is should be smaller. Then the more area available for water cement interaction per unit volume. What is fineness again? The more area is available for the water cement interaction. So we are adding water into the cement at that time, so there may be more area is required per volume, per unit volume. So that is the again factor is related to the fineness. Then the effect of greater fineness on the strength are generally seen during the first 7 days. If or you can you have seen also, cement is we are using the cement in before 1 or 2 month. मॅन्युफॅक्चरिंग डेट पासून आपण 1 ते 2 महिन्यामध्ये सिमेंट यूज करतो. व्हाय? So there are some specific reasons are there. If we preserve the cements, then you will not you will affect some of these physical properties, so that your strength will be reduced, or your heat of hydration process will be reduced, so the rate of strength also reduce. So for that, in first 7 days if we use the cement, it will be the better. Then when cement particles are coarser, so hydration starts on the surface of the particle. If the coarser म्हणजे large प्रमाणामध्ये जर सिमेंट पार्टिकल ची साइज असेल, so then the hydration starts on the surface of the particle. so that the coarser particle may not completely hydrated. See, the very important part is the hydration process. If your particles are not fine, the particles are coarser, then what will happen? Your hydration rate is will be the increased. म्हणजे सेटिंगचा टाइम आहे तो तुमचा लॉंग होत जाणार आहे आणि त्याचा अफेक्ट कशावरती होणार आहे? इनडायरेक्टली स्ट्रेंथ वरती अफेक्ट होतो. सो the coarser particles means large size particles are not hydrated completely. म्हणजे त्याच्यामधली हीट ही निघून जात नाही आणि ते कूल ज्यावेळी होतं त्यावेळी ते स्ट्रेंथ त्याला अचीव होते. ती जर हायड्रेट प्रॉपरली नाही झालं तर त्याला स्ट्रेंथ अचीव होणार नाही. सो दिस कॉजेस लो स्ट्रेंथ हिअर रिटर्न. This causes low strength and low durability. So why fineness is very important? Because if the fineness is in the limit or there are no coarser particles, then your strength will be, so hydration process will be good and the strength will be achieved in the time. So that is related to fineness of cement. So this is the physical property of the cement. You can see this picture. If we take this particular cement in hand, so if you see the fineness, जर आपण दोन बोटावरती घेऊन जर सिमेंट जर ते क्रश केलं तर त्या ठिकाणी एकही कोर्स पार्टिकल्स आपल्याला मिळाला नाही पाहिजे. सो इट मीन्स व्हॉट? इट मीन्स युअर cement is a finer and it will help for heat of hydration and indirectly it will help for the achieve the strength. So the second physical property of the cement is a consistency. So fineness is over. Second type of cement is second physical properties of cement is a consistency of cement. So what is consistency of cement? See, the ability of cement to flow in consistency. See, if we make or prepare the paste of cement, it means if we add the water in into the cements, at that time the paste will be prepared. So how much flow of that paste is nothing but the consistency. How much flow of that, if we prepare the paste, so if this paste is flowable or not flowable, that we can measure by from the Vicat apparatus. We are measuring consistency by Vicat apparatus. Vicat apparatus, it means flow of consistency. Flow, cement flow is a matter to the achieve the consistency. So it is measured by the Vicat apparatus. Consistency of cement is measured by the Vicat apparatus. In Vicat test, cement paste of the normal consistency is taken in the Vicat apparatus. See, just a minute. Okay, so in the Vicat test apparatus, the cement paste of the normal consistency is taken into the Vicat apparatus, as I told you. So everyone has, I think, seen the Vicat apparatus. So we are making the paste by adding the some proper water into the cement. We are making the paste and we are inserting the paste in the Vicat apparatus. Then the plunger of the apparatus is brought down to touch the top surface of the cement. So if you fill the paste in the Vicat apparatus, then plunger we will keep at the top of the your Vicat apparatus, and then the plunger will be penetrate. Then the plunger will be penetrated in the cement paste up to the certain depth depending on the consistency. So if we release the plunger in the cement paste by using wicket apparatus, it will penetrate at a certain depth. So a cement is said to have a normal consistency when plunger penetrates 10 plus or minus 1 mm. So total depth of wicket apparatus is how much? Who has no? So 10 plus or minus 1 plus or minus 1. So 10 mm the penetration will be required, then and then we can say the normal consistency of cement is there. The consistency of cement is a normal when we say the 10 plus minus 1 mm penetration is there in the cement paste. So this is the consistency of the cement. So you can see here, the wicket apparatus. So on this particular wicket apparatus, here the scale is there. So this scale means here this what we discussed 10 mm plus minus 1 will be shown here. This is the plunger. You can see here, this is the plunger. This is the glass plate on which we have placed this wicket mold. So this wicket mold is placed on the glass plate, and this plunger is we have to keep in the surface of this particular paste, and we have to release this. So if we 10 plus minus 1 mm penetration will be there, and so we can say the cement is having a normal consistency. So this is the consistency. Second physical properties. Then third physical properties of cement is a setting time. Third physical properties of cement is a setting time. So this is a very important physical properties which we have to test after the manufacturing of the cement. See, cement set and harden when water is added. When cement is hardened or set, if we add the water into the cement, then this cement time can vary depending upon the multiple factors. So there are so many factors affects the setting time of the cement. So which are these factors? So the factors are such as fineness of cement, cement water ratio, chemical content and admixtures. So these are the factors which affects the setting time. So the first factor is the fineness of cement, second factor is a water cement ratio, and third factor is the chemical content and admixtures we have used in the cements. So these three factors are affecting on the setting time of the cements. The cement used in a construction should have an initial setting time that is not too low, and final setting time are a measure. So we can measure two setting times, initial setting time and final setting time. So there is a limit. So how much initial setting time will be there and how much final setting time will be there. So here given two sentences. Initial setting time. So when pest begin with the stiffen noticeable, that is typically occur within the 30 to 40 minutes. So you have to keep in mind these values 30 to 40 minutes. So initial setting time is in between 30 to 45 minutes. It means not less than 30 minutes initial setting time should not be there. म्हणजेच इनिशियली सिमेंट जे आहे ते 30 मिनिटाच्या आत सेट व्हायला नाही पाहिजे. आर यू गेटिंग? सो इनिशियली your cement will not set less than 30 minutes. It will be set from 30 to 45 minutes. Then final setting. when the cement harden, being able to sustain some load below 10 hours. So the final setting time or finally cement will set not more than 10 hours. Within the 10 hours, it will be the finally set. If your cement will set within 10 hours, it will take the load or it will get the strength. So initial setting time should not be less than 30 minutes. It will be the 30 to 45 minutes, and final setting time will be the not more than 10 hours. It will be the less than 10 hours. So 10 hours means how many minutes? 10 into 6, 600 minutes. Total 600 minutes are maximum 600. Within the 600 minutes, our cement will be set. So third physical property is a setting time. This setting time is depends on the some of the factors that are the fineness of cement, water cement ratio, and the chemical content and admixtures. And if we test setting time of the cements, so there are two setting times: initial setting time and final setting time. So initial setting time will be in between 30 to 45 minutes. It means it should not less than 30 minutes, and final setting time will be the up to the 10 hours. It means it will not set after 10 hours. It means below 10 hours it will set, that is the below 600 minutes it will be the supposed to set. So this is the setting time. So you can see again here the same apparatus for the consistency and initial setting time we are using, that is the wicket apparatus we have seen. So this wicket apparatus having some if you see here, so plunger is there. We have seen this needle is fixed here. Then again at bottom this glass plate is there. The mold is placed down this plate. So this is the your mold. You can see here mold. So cement paste is filled in the mold. Cement paste is filled, and these are the needles. You can see here needles are there. These are the needles. So by using this wicket apparatus, we can see initial setting time up to the 30 minutes, not greater than not less than 30 minutes and not greater than 45 minutes. It will be the range between the 30 to 45 minutes. So by using this wicket apparatus, we can measure the initial and final setting time. Okay, so now procedure to finding the setting time of cement. So here the procedure they have given. If you see here, the apparatus required. So the wicket apparatus is required to find the setting time of the cement. Then balance means weight balance we required to take the weight of the cement. How much cement weight is required to prepare the paste for that. then measuring cylinder. So for the water measuring cylinder is required. Then stopwatch. So how much time is penetrated, that for that stopwatch is required. Then glass plate is required below, which we have to kept below in the mold. Then animal tray, it means for making the paste, so tray is required. And trowel, thapi, in we can say Marathi. So these thapi is required for making the cement paste. So these are the apparatus which we are required for preparing the cement and for taking the setting time test. Okay, so what should be the initial preparation for making the cement paste? See, we will see. See, the preparation, how to prepare the cement paste. So consistency test is to be done before starting the test procedure to find out the water required to give the paste normal consistency. See, to have consistency, initially we have to calculate the consistency of cement before we going to setting time of the cement. So if we have to perform setting time test of the cement, then we have to know the consistency of that cement. So what is consistency? Consistency is, it means the cement paste is flow. How much water we can add for that cement paste will be flow. So that depends on the and the normal consistency. When we say the normal consistency, if the 10 plus or minus 1 mm penetration will be there, then normal consistency will be there. So how much percentage of water we have added for the normal consistency, that we have to find initially. Then take 400 kg of 400 gram of cement. How to perform test? 400 gram of cement and prepare a neat cement paste with a 0.85% of water by weight of the cement. So how much cement we have taken? 400 gram. So out of that 400 gram, for the 400 gram, so 85% or 0.85%, 0.85% of water we have by the weight. म्हणजे 400 ग्रॅम आहे तर त्याच्या 0.85% एवढं वेटचं वॉटर घ्यावं लागेल आपल्याला. सो दॅट वॉटर and this cement 400 gram cement we have to add. So gauge time is kept between 3 to 5 minutes. It means the preparation process, पाणी ज्यावेळी सिमेंट मध्ये ऍड करणार आहे, at that time this preparation process is in between 3 to 5 minutes. We have to add water in between 3 to 5 minutes. It means we have to make a paste within the 5 minutes. Then start the stopwatch at an instant when the water is added to the cement. Record the time T1. We have to start the stopwatch at what time T1 we have added the water, and T1 time we have to record. So fill wicket apparatus. Fill wicket apparatus. It means whatever paste we have prepared, that paste we have to fill in the wicket apparatus. After that, the resting on the glass plate. So that wicket mold we have to rest on the glass plate. So which with the cement paste gauged as above, and fill mold completely and smooth of the surface of the paste. So whatever that mold is there, that mold you have to fill completely of the paste, making it level with the top of the mold. So we have to level the top of the mold. Then the cement block thus prepared is called as a test block. So whatever cement paste we have filled in the wicket apparatus, that block is generated, that block we are calling as a cement test block. So this is the preparation process. So test. So now we have to test take test on the initial setting time. So how we can take the test? The sample is prepared, and we have filled that sample on the in the particular wicket apparatus. Now we have to test take the test. So test for initial setting time. So place the test block, confirm in the mold, and resting on the non-porous plate. So under the water bearing is a needle. So whatever plate we have kept in the glass plate, so this is not a porous. Glass plate means it is not porous. म्हणजे porous का वापरायची तर त्यात वॉटरचं absorption झालं नाही पाहिजे. So it is a non-porous. So this is first. Then lower needle gently until it comes in the contact with the surface of the test. So needle we have to take at the surface of the sample, then test block, and quick release, allowing it to penetrate into the test block. So similar to consistency, we have to penetrate the needle into the test block, whatever test block we have prepared. So in that test block we have to penetrate or allowing to penetrate the needle. Then in the beginning the needle completely persists with the test block. म्हणजे at the beginning of the your test, so you have prepared the sample, you have filled in the wicket apparatus, and what happen if you take the test initially, the penetration will be more, but repeat this procedure. पेनेट्रेशन व्हायची प्रोसिजर ही रिपीट करत राहायचं कधीपर्यंत, that is quickly releasing the needle after every 2 minutes. So we have to repeat the procedure of this inserting the needle every 2 minutes till the needle failed to pierce the block for 5 mm measured from the bottom of the mold. So total 40 mm depth of mold is there. So and we have to insert the needle. So how much from bottom 40 bottom 5 mm, it means from top it is 35 mm. So 35 mm the penetration should be required. So that time is we have to note, that is the T2. So first preparation time is 5 minutes, तोही नोट करायचा. त्यानंतर T2 time, for every 2 minutes we have to measure up to when you will not get 5 mm measured distance from the bottom. जोपर्यंत खालून 5 mm bottom पासून 5 mm distance आपल्याला मिळत नाही पेनिट्रेशनचं, up to that time you have to take the release the needle in the that wicket apparatus for every 2 minutes. Then this is the your initial setting time. Then next is the final setting time. So see, test for final setting time. For determining the final setting time, replace the needle for the wicket apparatus by needle which annular attachment. So for the initial setting time, the needle is up having a sharp edge, म्हणजे सुई सारखा मराठीत म्हणतो तसा needle असतो. आणि final setting time, the needle we are using for final setting time having a annular attachment. It means this having a base, so that final setting time needle we have to attach to the that wicket apparatus. Then the cement is considered finally set when upon applying the final setting time needle gently to the surface of the test block. So after the initial setting time, we have to some distance, some time we have to add attach the needle, and we have to release the needle. So the marking of that needle should, so see the needle makes an impression. ज्यावेळी तो आपण needles ज्यावेळी पेस्ट वरती प्रेस करतोय त्यावेळी आपल्याला काय इम्प्रेशन्स दिसतात. सो दॅट इम्प्रेशन्स time is recorded. So that impression should not be there. So at what time impressions are not there, that time we have to record, that is the T3, and that is the final setting time. So this may be after more than 200 minutes, 300 minutes, 400 minutes, but not more than 600 minutes. 10 तासापेक्षा जास्त नसायला पाहिजे तो. म्हणजे प्लंजर जर आपण फायनल सेटिंग टाइमचा प्लंजर जर आपण सोडला सिमेंट पेस्ट वरती, तर त्याचं मार्किंग, त्याचा शेप इन्सर्ट झालेला दिसला नाही पाहिजे. तो किती टाइमला दिसतोय, दॅट इज नथिंग बट युअर फायनल सेटिंग टाइम. दॅट इज द टाइम यू हॅव टू measure that time in the stopwatch. That is the T3. So the final setting time should not be more than 10 hours and initial setting time should not be less than 30 minutes. So that you can learn from this particular initial setting time and final setting time. So these are the calculations we can see. So here initial setting time T2 minus T1, where T1 is a time at which water is first added to the cement. T2 is a time when needle fails to penetrate 5 mm to 7 mm from the top of the mold, and T3 is a time when the needle makes the impression, but the attachment fails to do so. So these three were T1 is the preparation time, T2 is the initial setting time, and T3 is the final setting time. This will the calculation of the particular setting time. Okay, so this is related to third physical property of the cement, that is the setting time. So in that initial and final setting time we have seen. So the remaining part we will see the soundness of cement. This is the again one of the physical property of the cement that we will see in the next lecture. So our time is now about to close. So we will stop for today. So wait, I will take attendance and we will close our lecture.